Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today's focus is going to continue with trigonometry, but we're going to talk about two different types of angle vocab that you may hear in word problems, angles of elevation and angles of depression. So it's important to know what those angles are when you read them so you can accurately draw your diagram, which will allow you to set up your equations correctly. All right, we are going to skip the do now. That's pretty standard review. I like to save most of this time for new stuff today. And let's jump down to the second page. Let's do vocab first. So again, angles of elevation and angles of depression. Well, an angle of elevation is an angle formed by a horizontal line and a line of sight to a point above the line. An angle of depression is an angle formed by a horizontal line and a line of sight to a point below the line. So here's two examples in this photo. Your angle of elevation, people looking from the observatory tower up to the plane. And again, this is the key, right? We are looking at angles formed by the horizontal, right? Either way. So we have the angle formed by the horizontal and their line of sight up to the plane. For the person in the plane, we have, again, an angle formed by the horizontal and down to the people in the observatory tower. So those are what angles of elevation and angles of depression look like. Now, there's a common misconception that you see with students, and it's generally with angles of depression. So let's say that there's someone, let's just put them, I don't know why I thought of this example, but let's just say they're standing on top of a box. So there's someone on top of a little box, and they are looking down at something. A lot of students say that the angle of depression is this angle right here, theta. The problem is, right, if we go back up here, an angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. So it's formed by the line of sight, but the line of sight with the horizontal. So you have to draw in the horizontal line to form that angle of depression. So the angle of depression is an angle below the horizontal line, but it's formed with the horizontal. So again, biggest misconception we see here with students is that they label this angle as the angle of depression, but that angle, there is no horizontal line there to form that angle. So that cannot be the angle of depression. So something to keep in mind. That's generally where students go wrong here. Quick practice. For number one, there are four angles given there, 3, 4, 5, and 6. Think about which of those are angles of elevation, which are angles of depression, and maybe there's an angle that's neither there. Okay, so angles of elevation, again, those are angles that are above the horizontal. So we have a horizontal right here. 6 is above the horizontal. So that is an angle of elevation. We have another horizontal here. And 4 is that angle above the horizontal. So we have 4, we have 4 and 6 angles of elevation. Let's see what our angles of depression are. Again, let's look for those horizontals. We have an extra horizontal up here. So angles that lie below the horizontal and formed with a line of sight. Let's do better with that. So we have angle 3 and angle 5. Those are both angles below the horizontal, yet still formed with the horizontal, so 3 and 5. Okay, let's do at least one of these problems. Maybe we'll have time for 2. I'm actually going to go back up here to this first one. So it says, suppose one of your friends is at the top of the stratosphere and you're standing on the ground. If you're looking up at them with a 55-degree angle, your eye is 5 feet above the ground and you're standing 805 feet away. How high above the ground is your friend? Round to the nearest foot. Well, pause the video. First, see if you can draw an accurate diagram correctly labeled, and then see if you can set up, a trig equation to figure out how high your friend is above the ground. Okay, so I'm going to start by doing a little sketch of the stratosphere. We know that, we're trying to figure out, we know your friend is up here. So that is the distance we're trying to find, right? That is our x. It says that you are standing on the ground, not drawn to scale, obviously, and you are looking up at them with a 55-degree angle. So looking up at them with a 55-degree angle, this would be an angle of elevation, right? So this angle of elevation is 55 degrees. We can also sketch in some vertical right here. This would be a right angle. It says your eye is 5 feet above the ground. And we are standing 805 feet away. So 805 feet. So we're trying to find x. Now, a couple things we need to think about here. First off, we have this black triangle, which would be good to use for to come up with our trig equation. However, we also have this red x, which is not quite the length of this dashed side of our black triangle, right? This dashed side right here is not the same as that red x, because there's this little extra piece down here that's not included with the black, but it is included with the x. So can we write an expression for the orange dashed side of the black triangle? Well, the orange dashed side of the black triangle is 5 feet less than x. So this would be x minus 5, right? If the entire distance from the top of the stratosphere to the ground is x, but your eyes are 5 feet above the ground, well, total distance minus the 5 feet would be x minus 5. Now we can set up an equation to figure out what x is and then figure out the height of or how high your friend is above the ground. This is my reference angle right here, 55. This makes this side the opposite, this side the adjacent. We are going to go into our tangent ratio. So I have tangent of 55 degrees is equal to x minus 5 all over 805. Well, I can just punch in tangent of 55. Remember, you can go to your Desmos scientific calculator that we've talked about in the last couple of lessons. Tangent of 55 gives me approximately 1.428. Remember, if we're rounding in the middle of a problem, we're going to go to 3 decimal places for this class. And then I can just repeat my other fraction. Let's put this over 1, and I can cross multiply. Or again, cross multiplying may seem a little too much work. Because our x is in the numerator, it might just be easier to think about this as multiplying by 805. Again, cross multiplying gets you there. But we really don't have to multiply twice here. We just need to multiply by once to clear the fractions. So 805 times 1.428 is 1149.54 is equal to x minus 5. And if I add 5 to both sides, I'm going to get 1154.54 is equal to x. And this is really approximate, right? Because we've rounded, so our final answer should just be approximately equal to. If we're rounding to the nearest foot, that is going to give us 1,155 feet. And we did label x as the entire height of the stratosphere, so we're good. We don't have to do any extra work here. It's approximately 1,155 feet to the top of the stratosphere. Okay, we do have time for one more. Let's try another diagram problem. Sometimes the hardest part of these problems is setting up the diagram correctly, because we should be getting pretty good with solving those trig equations. Let's do number 3. So go ahead, see if you can sketch a diagram, label it properly, and then set up a trig equation that helps you solve for whatever they're asking you to solve for. Then come back, join us for a final discussion, and we will be done. Okay, so it says a forest ranger is in a 90-foot observation tower. So we'll just put him up at the top of the tower. That's 90 feet. And he sees a fire. The angle of depression to the fire is 7 degrees. So he's looking down at a fire. And the angle of depression is 7 degrees. Now here's what we have to be careful of, right? The angle of depression is formed by the horizontal. So it's this angle here that's 7 degrees. It is not this angle right here, right? Because you have to form these angles of elevation and depression with a horizontal line. And let's clear this up. Let's make this a little more clear, actually, just so we know we're going down to the bottom there, all the way to the ground. There would be a right angle. And it says, what is the horizontal distance between the tower and the first? Well, what I meant to say was tower and the fire. So we're trying to find the horizontal distance. Well, that's going to be, it's going to be x. And I could also label this vertical distance over here 90 as well, right? Because both of those vertical distances are going to be the same. So if I'm looking at that right triangle, if I look at my reference angle, which is 7 degrees, well, this 90 feet is the opposite side. X is the adjacent side. Looks like I'm using tangent again, but our x is in a different spot this time. So I'm going to have tangent of 7 degrees is equal to opposite, so 90 over x. Let me just show you another way to solve this, which would actually help make your answer a little bit more precise. You actually don't have to type in the tangent function, the sine function, or the cosine function right away. You can just work with that as you do your inverse operations and punch it in at the very end. Here's what I mean. All right, let's just leave that. Let's put it over 1, and let's cross multiply. So I'm going to get x times tangent of 7 is equal to 90. If I want to get the x by itself, I'm going to divide both sides by tangent of 7. So x is equal to 90 divided by tangent of 7. And you could punch that entire quantity into your calculator at once. Again, it's going to give you a more exact answer rather than if you round in the middle of a problem. I know I've said that you can round in the middle of a problem, and as long as you go to 3 decimal places, you'll be okay in this class. As you move into higher level classes, certain teachers may prefer that you keep the trig value, you keep the exact value. So you don't round in the middle of a problem, you just do it at the end, because it is going to make your ending answer more precise. So if I punch all that into a calculator, 90 divided by tangent of 7, that gives me approximately, we're rounding to the nearest foot, 733 feet. So the fire is approximately 733 feet away as far as horizontal distance goes. All right, that is going to wrap it up for this lesson. We'll have time to finish those other word problems in class. As always, enjoy the rest of your day, and we will look forward to seeing you next time.